Now, here is a question which says the set of values of x satisfying the inequation x plus 1 upon x is greater than or equal to 2. That is the first one for us. Second one is x minus 1 whole cube into x plus 1 is less than 0. And then there is a third one, 5x minus 1 is less than x plus 1 whole square minus, and that is less than again 7x minus 3. So these are some of the type of questions that you might expect or you might come across while studying your 11th and 12th. So here in this session we are going to discuss about some of these inequalities. Now before we discuss these equations and how do we proceed in order to solve them, let us first discuss some of the different basic terminologies and the way to solve such questions. So before we begin solving, let us understand the concept of intervals. Intervals are basically of three types. First one is known as closed interval. Second one is known as open interval. And the third one is known as half open, half closed. So what do we basically mean by these three intervals? Now, in order to understand the first one, think of a number x in the following manner. If x is a number such that a is less than or equal to x and which in turn is less than or equal to b. So let us try to understand how do we represent it first on a number line and how do we express it in form of an expression or how do we write it mathematically. So if suppose we have a number line, here is let us say 0. On the positive side we have positive numbers and on the left side of 0 we have negative numbers. Let us say there are 2 points A and B as follows. So note A and B are located on the positive side. It does not matter whether it is located on the positive side, negative side, or one either way, that is one on the left and one on the right. Now in order to represent all the solution or all the x which lies in between A and B, including A and B, we do the following. We make a circle at the point A, which is colored, and then we highlight the portion between A and B. So this is how we represent the solution of x if A is less than x, which is less than equal to b. So this is how we represent the solution on a number line. Now if we want to write it mathematically, we represent x as x belongs to, there are two numbers, first the smaller one which is a, and then we put a comma and then we put the upper limit which is b. Now since these both are included, we put square brackets on both the sides, and this is known as closed interval because the endpoints are included in the solution set of x. So this is how we represent x in terms of equation and on a number line. So this is how we represent x mathematically and on a number line. Now similarly, if you want to ask how do we represent an open interval, so let me first write the condition. If x is a number, real number, such that a is less than x is less than b. Now note the difference between the first and the second one. Here equal to sign is not there, neither it is with a nor it is with b. So if we want to represent the solution set of x in this case on a number line, so let us first have a number line. Let us take origin, and it does not matter where we take A and B. So let us take this time A and B on the left side of 0, that is on the negative x-axis. Now in this case, since A and B are not included in the solution set, we have to represent in the following manner. We make a circle at A, we make a circle at B, which is not colored inside. So that is a hollow circle we make, we say, and here in this case of the closed interval, we had a solid circle. Here we have a hollow circle. Now since all other values except A and B and in between A and B are the solution set, we again highlight the portion in between A and B. So that is how the solution set of X is represented on a number line. So after this, you might ask how to represent it mathematically, and mathematically we write X belonging to the lower limit, comma, upper limit, that is A and B, and then we put round brackets on both the ends. So this is also known as parentheses. So this is how we represent open interval. Now that we have studied the closed and the open interval, half open and half closed would be very simple for you to understand. So let us say here we have a number X belonging to real numbers such that A is less than X is less than equal to B. Now you could also have the case when A is less than equal to X, which in turn is less than B. So how do we represent in this case? So first let us take the number line. Let us have a 0, A and B. Now here B is included in the solution set of X. So what we need to do is we need to make a solid circle at B, and since A is not included, we make a hollow circle at A. So we make a solid circle at B and a hollow one at A, and then we highlight the portion in between A and B. And mathematically we can write X belonging to A is not included, so we need to put round bracket A, comma, upper limit, which is B. Now B is included in the solution set, so we put a square bracket. So this is a set which is half open and half closed. Now this is also represented at times in another way, which is now the reverse side of the opposite bracket we take first, and then we close it in the following manner. Now this shows that A is not included. If these two lines which were inside, if they were inside, it means they were included, and since we have turned them around, we have done a rotation along the vertical line, now it means A and B are not included. So this is another way of representation of the open interval. So again, similarly, we can also represent the half open and half closed set or interval in the following manner. Now you might also come across infinity sometimes. Let us say we want to represent all the numbers which is greater than, let us say, 2. So the question is, represent the solution set for X greater than equal to 2. So how do we do this? So first we need to have our number line. Let us mark origin and the number 2 here. So our solution set is as follows. Now since 2 is included, we need to make a solid circle at 2 and highlight all the portion on the right side of the number 2. Now if we want to express it in the form of intervals, open and closed, with the help of brackets, we have to write X belongs to, the lower limit is 2, upper limit is infinity. Now 2, since it is included, we have to have the square bracket. So the question here is, which bracket do we put on the right side? Shall we put closed one or shall we put open interval? The the idea is infinity is something which is not bounded. By the word not bounded is what I mean is it cannot be contained in some number. Now when I say b lies in the solution set. B is the limit of the solution, but infinity cannot be the limit of any set, because infinity is something which we do not know, which is not defined. It just goes on increasing and increasing. So by definition and by convention, infinity is always going to be open-ended, and hence we have to put the round bracket on the side of the infinity. Now it could also be the case that the solution we had to find for the case when x is less than equal to 0. Now here x was greater than equal to 0, and in this case, second case, we have x less than equal to 0. So how do we do it in this case? So since it is less than equal to 2, if I mark here itself, it is going to be the following. So imagine I'm taking a number line here. This is again origin, and this is coinciding with 2. Now our solution set will be from this point 2 and all the points which are lying on the left side of 2. So mathematically we can represent it as x belongs to minus infinity comma 2. Again, since 2 is included, we have to put a square bracket here, and minus infinity by definition and convention, and you also understand now that cannot be included, and hence we put a round bracket on the left side of this set. So this is how we represent the solution set in following cases. Now that we have understood how do we represent the solutions, let us try to solve the questions that we have here one by one. So the first question is x plus 1 upon x is greater than equal to 2. So if you look at the question, so let me write it here. The first question is x plus 1 upon x is greater than equal to 2. So what we next do is we write x plus 1 upon x minus 2 is greater than equal to 0. Then we write x plus 1 minus 2x upon x is greater than equal to 0. Later